This crazy machine. How are you supposed to do that? Gotta have something. No, it's not about calibration. It has something to do with this. I will recalibrate because I kicked that thing. Get this again. Try it again. Exponents. I think we've talked about this before, but I'll give you a quick version of this. Let's say you've got 5 to the third power. You should need to know the names of these. This is the exponent slash base or slash power. And we've talked about this, and this is the base. Got it? Good, yes. And the exponent tells you you need to multiply the exponent number of bases together. Okay, which very simply means this. The number 3 up there tells you that you have 3 5s times themselves. 5 to the third power equals 5 times 5 times 5. Please don't think that it is 15. It's not 3 times 5, it's 3 5s times themselves. There's a difference there. Okay. 3 times 5 is 3 5s added together. 5 to the third power is 3 5s times each other. And that's going to be 125. Nothing new, nothing borrowed, nothing blue there, right? You can't get married with that, that's for sure. Everybody's good with that?
Yes.
Okay, now, here's what we're going to talk about. We're talking about the exponent rules, or the laws of exponents. The laws, well, I'm going to start a whole new page. The laws of exponents. And here are the 3 cases you're going to come across, and I'm going to use a letter. What is the difference between when I have x to the third power plus x to the third power, or when I have x to the third power times x to the third power, or the last one is, what if I have x to the third power all to the third power? And people get those mixed up because they're not the same. Okay, I'm going to try to alleviate your pain on this and put it all on one page. This one, let's start with this. If you have x to the third plus x to the third, you're adding them together. Okay, nothing changes with it's just like having x plus x. What do you get if you add x plus x together? No, you don't get x. X plus x, how many x's do you have? You get 2 x's. Okay. Same thing this. X to the third plus x to the third is 2 x to the thirds. Okay. It doesn't change. The exponent doesn't change. They only change when you multiply them together. Okay. So if I gave you x to the 5th plus x to the 5th plus 2x to the 5ths, how many total x to the 5ths do you have there? Cameron? 4 of them. It's 4x to the 5th. That's what that would all simplify down to. Okay. That one you should know. That's really not part of today, but I wanted you to see that. Now, x to the third times x to the third. A lot of people think that because you're multiplying there, you're going to get x to the 9th power. Well, let's think about this though. What does x to the third really mean? Third power means I have 3 x's times themselves, right? This is x to the third, correct? Well, if I'm multiplying 3 x's times another 3 x's, or without parentheses, it would look like this. Guess what I get? X to the third times x to the third, Logan, is
X to the 6th.
x to the 6th power. Okay. Or if I have this, let's do b squared times b to the 5th times b to the 4th. How many b's are you multiplying all together there? You're multiplying 2 together there, 5 together there, 4 together there. Simplified, this is going to be b to the what power?
7.
Did you say 7? You losing Cabran? B to the 11th power. That's a 2, I don't know if that maybe messed up there. So the rule is this. When you multiply two exponents together, in this case, you always add exponents. For this one. I should see how hard the problems are really. Not too much though. And then this one here, x to the 3rd power. What do you suppose that means? Well, let's look at what it means. Well, this power tells you you have 3 of these times themselves. So you end up with x to the 3rd times x to the 3rd times x to the 3rd. Which really turns it back into this problem here. What is x to the 3rd times x to the 3rd times x to the 3rd? Brooke? X to the 9th power. So what is the rule, would you suppose, when you have an exponent to an exponent? In this case, I added exponents. In this case, like if I had this, what if I had x to the 8th power to the 5th power? I have x to the 8th times 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 x to the 8th. Maggie, the answer is correct. When you have exponents to exponents, exponents to exponents get multiplied. And in this case, so if I have x to the 8th times x to the 5th, you end up with x to the 40th power. 40 x's times themselves. And then I do have one more I should have put on there. And the last one we need to actually look at is this one. What if you have x to the 5th power over x to the 3rd power, which is really division? What do you get? And again, if we write this out, it's a little bit easier. What is x to the 5th power? You've got 5 x's on top over 3 x's on the bottom. What can you do when you have the same thing on top as the same thing on the bottom? You can cross off 1 for 1. This 1x will cross off with that 1x, second x with the second x, third x with the third x. And my answer I'm left with on top is 2x's times themselves, Andrew, which is
X to the 2nd power.
x squared. So what do you think the law of exponents says when you divide? Shall I do another one? Like if I had x to the 15th power over x to the 10th power, my answer is going to be x to the 10th power, because I have 15 on top and 10 on bottom, and 10 of those are going to cross off with the 10 of the 15 on top. I'm sorry, that should have been a 5. Sorry. Just checking to see if you're watching. What do you suppose the rule when you divide is? Logan?
You're supposed to cross cancel out there. So.
Yeah, but there's a simpler way to say it. No, I can't get any place to write it here. When you divide, Maggie?
When you subtract.
Yeah, you subtract exponents. Now you have to be careful. In order to do that, they have to be the same bases. Okay, in other words, this, if you had x to the 5th power over y to the 3rd power, you can't do that there because they have to be the same. They have to both be x's. Okay, you would not get xy to the 2nd power. Okay, they have to be the same bases. They have to be an x and an x. Okay. The other thing you have to watch out is, what do you suppose would happen if you did this, you being smart people? What if I had x to the 8th power over x to the 10th power? if the rule is to subtract, and you're always going to subtract the bottom one from the top one, guess what you actually get? What if you take 8 and subtract 10 from it? Ron?
You get x to the negatives.
Negative 2 power. Is 10 from 8, 8 from 10 is 2. We won't run into too much of that, but it's good to know. As they don't give you a lot of the variable ones, but they do some number things. Like, oh, I guess they do some number things. Let's see what else they do. Maybe they don't get real hard ones, I guess. I probably did harder ones than you're gonna get there. They will say this, what is, whatever that is, 10 to the 8th times 10 to the 3rd. 10 to the 8th power times 10 to the 3rd power will give you what? You don't have to do this out, just write it in exponent form. 10 to the 8th times 10 to the 3rd, Ryan Connor, is? 10 to the?
24 power.
Nope, that would be this, and that's why this is confusing. That would be exponent to exponent. If they're both written there and they're times there, you have 8 tens times another 3 tens, Ryan, you'd get 10 to the Grace? 11 power. This would be 10 to the 24th power. Exponents, 2 exponents get multiplied, bases, 2 exponents get added, subtracted there. How about this one? 8 to the 8th power over 8 to the 4th power would be, in exponential form, 8 to the what power?
8 to the 4th power.
8 to the 4th power. Believe me, you'll get plenty of practice at this to be able to figure that out. How about this one? What about this one? Y to the 5th power plus y to the 5th power. Y to the 5th plus y to the 5th. Hellhammer?
Y to the 10.
It is not. That would be y to the 5th times y to the 5th. This is y to the 5th plus y to the 5th.
Y to the 20.
It would not be. That would be y to the 5th power to the 5th power. Here's what you're thinking. First time you thought this, y to the 5th times y to the 5th. That is, in fact, y to the 10th power. The second time you thought y to the 5th to the 5th power. That is y to the 25th power. This is adding y to the 5th plus y to the 5th. Taylor, you get 2y to the 5th. Yeah? How about this? X times x times x times x is, Alex?
X to the 4th power.
X to the 4th power. X plus x plus x plus x is, Leon?
4x.
4x. And x to the x power times x, or to the x to the x power to the x power. See if you can make, see if anybody can make a deductive leap on this. You'll never be asked this, but I'm just thinking it's fun. X to the x power to the x power would equal, David says?
X to the x power.
No, that's what it started out being. Brian?
X to the x power squared.
Yeah, I think you got it. X to the x squared exponent. Because when you multiply exponents times exponents, or exponents to exponents get multiplied, so that doesn't make a lot of sense, but it's true, huh?
We're not doing that
Yeah.
yet.
But I just thought, you know what, you should be able to make some of those deductive leaps there.